Okay. So 9.2 give you 6 more formulas. Again, you're going to get a formula sheet. However, there's only 2 this entire unit that you have to memorize. Those are going to be given to you today, and I'll tell you which ones they are. They're pretty easy to learn. Only 2 out of the 18 or whatever there are that you have to memorize. Double angle and half angle formulas. Okay. Well, let's just start with the one we proved in the homework on accident. The sine 2 theta. Remember how we split it up into theta plus theta? Well, we know that we got 2 sine theta cosine theta for that formula. This is actually the one out of the 2 that you must memorize. You will not be given this formula on your formula sheet. You'll have all the ones from yesterday, and most of the ones from today, and all the ones from tomorrow, or from 9.3, whenever we do that. We won't do that tomorrow. The next formula, we're going to go ahead and prove, because you know what we're going to do? You've noticed that there's homework questions that have some identities, not harder ones, but just kind of using these new formulas. So these are actually pretty easy to prove, okay? Cosine 2 theta. We're going to use the hint from the homework and write 2 theta as theta plus theta and just see what happens, okay? So when we have 2 angles, the addition formula for cosine says that this is cosine of angle 1, cosine of angle 2, plus is minus, right? Sine of angle 1, sine of angle 2, and we can clean this up a little bit. Cosine times cosine, if it's the same angle, is cosine squared, and then sine times sine is sine squared. So actually, this is the other formula that you must memorize. These are the only 2 this unit that are new that you have to know. Okay, so what formula should you know? You should know all the Pythagorean identities. Cosine squared plus sine squared is 1. 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. Those are the main 3 that we did last semester. Your basic definitions for, like tangent, sine over cosine, and so on and so forth. But you guys all know that. And then now we're adding these 2. Okay, all these other ones that we've been dealing with and will deal with will be on a formula sheet for you. Okay, so let's actually just write out the other ones. They can pretty much, this one is pretty similar to the other ones. If you wanted to prove it, you can do tangent of theta plus theta to see that the formula is what it is. But here's what you're going to end up getting. The tangent of 2 theta is going to be 2 times tangent theta over 1 minus tangent squared theta. Okay, so these are the double angle formulas because 2 theta is the angle. It's being doubled. Okay. The half angle formulas, so these were double. Half angle looks something like this. Sine of theta over 2 is going to equal plus or minus the square root of 1 minus cosine theta all over 2. And I should clarify that you have to choose which it is. And this is based on where theta over 2 is. Okay? So, we'll do an example here in a little while where we figure out where it is and all that, but not plus or minus for the final answer. It's one or the other. Okay? The cosine of theta over 2, same idea. In fact, it's the same exact formula, just 1 plus cosine theta instead of 1 minus cosine theta. And now the tangent of theta over 2. What am I doing? That does not have a square root. Sorry about that. Let me start over. Tangent of theta over 2 is sine theta over 1 plus cosine theta. Okay, so these are the 6 formulas that we'll deal with in this section. Tangent of theta over 2, cosine of theta over 2, sine of theta over 2. Again, the only 2 you have to memorize are sine of 2 theta and cosine of 2 theta. Okay? Those are the only 6 we're going to deal with today. There's more in 8.3, but again, those will be on a formula sheet. 9.3, thank you. All right, so let's do a couple of examples. Maybe 3 if we have time. Yeah. Well, yeah. I have about 22 minutes. Oh, we got plenty of time.
13 is the block.
Yeah, so 17. Okay, first example. If x equals 5 sine theta, and we know that 3 pi over 2 is less than theta, which is less than 2 pi, express sine of 2 theta in terms of x. Okay, so the technique that we're going to use is similar to what we did yesterday. If this is what they want, what we're going to do is write the formula for it. Okay, so what's sine of 2 theta? 2 sine cosine. And now we ask the question of, do I know either of these? And the answer is no. So let's see what we do know. We know that x is equal to 5 sine theta.
Where are the x's?
So couldn't I figure out sine theta from this equation? How do I get sine theta by itself? Divide by 5. So let me write this out. Sine theta is actually x over 5. You guys see where I'm getting that from? Okay. Now, to figure out cosine theta, I could use the fact that sine is x over 5 using a right triangle to figure out the adjacent side, which would be the square root of hypotenuse squared minus other leg squared. So now cosine would be adjacent over hypotenuse, so root of 25 minus x squared over 5. And now I do want to point out something. That's so theta is from 3 pi over 2 to 2 pi. So, yeah, sine theta should be negative. And cosine theta over here in quadrant 4 is positive. So then our final answer is going to be negative 2x square root of 25 minus x squared. and then we combine the denominators, multiply it out, we get 25.
That's all you do?
For this one, yeah. I mean, you guys see that it's really the same thing we did yesterday, just a slightly different formula, right?
I do.
Okay. Any questions on this example? All right. Let's try. If tangent theta equals 4/3 and theta is between, let's go 3 pi over 2, 2 pi again. Actually, no, I lied. That's not what I want. Let's do pi and 3 pi over 2. Let's say we want to find cosine of theta over 2. Okay, so we know that the tangent is 4/3. We know our angle is in what quadrant? Third. But now we're interested in half of theta. Okay, now we're interested in half of theta. So what we can do is take this inequality first, and I'm going to divide everything here by 2. You guys see what I'm doing here? Because I want to know where theta over 2 is going to be. So if I divide everything by 2, half of theta will be between pi over 2 and 3 pi over 2 divided by 2 is the same as 3 pi over 2 times a half. So 3 pi over 4. So where is that? It's in the second quadrant, specifically between 90 and 135, but all we care about is what quadrant it's in. Okay? Now we use the formula. So cosine of theta over 2 is, and this is why I did all this, we pick one or the other. We don't want plus or minus. We have to make a decision. Theta over 2 was in quadrant 2, right? So cosine should be negative. And now we just do the rest of the formula, which is 1 plus...
Why are we doing anything with tangent?
We will.
Can you just do the triangle thing?
Well, we will. We're getting there. So it's 1 plus cosine theta over 2. Okay, and this is what Katie was talking about. So the only thing I have to figure out then is what the cosine is, right? So if I know this much... A lot of arrows here. We can draw a triangle. Opposite over adjacent is 4 over 3. So what's the hypotenuse? 5. So then, now we go ahead into the formula, and for cosine of theta, I do 3/5, because it's adjacent over hypotenuse. But we got to make a decision for theta as well. Theta was originally, so I should maybe draw, this is theta over 2. Where was theta? Third quadrant. So in the third quadrant, is it clear that cosine is negative? So it's 1 plus the cosine of that angle, which will be negative 3/5, because we're in quadrant 3, divided by 2. And now we clean up. Let's see. 1 Well, maybe we do it the same way we've been doing it. Multiply everything by 5 in here to get rid of the little denominator. So now we get what? Square root of 5 minus 3 all over 10, which is the negative square root of 2/10, which is the same as the square root of 1 over 5, which is 1 over root 5. Don't forget the negative, and then we can clean that up and make it negative root 5 over 5. Okay, so there's a lot of little steps. The big steps is knowing what formula to use, how to plug everything in, knowing where the minuses and pluses go, and then after that it's really just, sorry to say it, but it's just algebra. Simplifying, cleaning things up. Are we good with that problem?
Yes. Let's go back to geometry.
Question? Nope. Okay. We'll do 2 more. Evaluate tangent of 105 degrees using a half angle formula. Now, just to clarify, yesterday we could have also done this question, right? Split up 105 into 2 nice angles, what would they have been? 45 and 60. So we could still do it that way, right? But if we're using a half angle formula, just so you can see how that works, now what we want to try to do is say, well, what angle do I divide by 2 so that it's still technically 105? 210, okay. So does everybody see where I'm getting this 210 from? Because half of 105 or half of 210 is 105. Okay? So the idea is I don't know tangents of 105, but if I make a 210 degree angle, I know about 210 because that's one of the values along the unit circle. So now what's the formula for the half angle of tangent? Sine theta, and let's clarify. Theta in this case is 210. Does everybody see that? So let's rewrite everything. Sine of theta will become sine of 210 over 1 plus cosine of theta, which is 210. What's that?
Oh, okay.
Yeah, it's just the same theta from the theta on top of the fraction. And now we just do some trig. The sine of 210, Saeed, is what?
210.
Mm-hmm.
It's 7, 5, or 6.
That's the angle, but what's the sine of 210?
It's
Is it negative?
negative 1 over 2.
Good.
That's the sine side. Cosines.
1 plus, what's the cosine of 210 then? Negative root 3 over 2. Very good. Now we just clean up the fractions here. So double the numerator, double the denominator. We get negative 1, or not negative. Oh yeah, negative 1 over 2 minus root 3. Multiply. You don't mean reciprocal. I know what you mean though. Conjugate, very good. So now we get negative 2 minus root 3, that's the numerator. And then the denominator, difference of squares, middle terms cancel, we get 4 minus 3. Well, that's nice, it's just 1. So the final answer is negative 2 minus root 3. You guys kind of see how to work with these?
Yes, sir.
Jack, you got a question? Okay. All right, last problem that we're going to do today. Question, Kevin? Nope. Okay. Prove that sine 3 theta is equal to 3 sine theta cosine squared theta minus sine cubed theta. What do you guys think? Yes?
Do like side 2 circle plus one of them.
Yes. It's a great idea. So let's take the left-hand side and say that that's equal to sine of 2 theta plus theta, or circle with a line, or whatever you called it, plus one of them. And now this looks a lot like sine of an angle plus another angle, right? So do we have a formula for that? Careful. It's not double angle yet. We're thinking of this as your S and that is your T. So it's kind of like sine of S plus T right now. Yeah, we're making it into its long form. So it's going to be sine 2 theta cosine theta plus cosine 2 theta sine theta. Good. And now if we're looking at where we're at and where we need to end up, you see the right-hand side has all thetas, right? So do we have a way of changing these? Well, we could split them up, but we have a shortcut now, right? Now we can use the double angle formula for sine. What's sine 2 theta? 2 sine theta cosine theta. So that is our new first part, times cosine theta. Plus, and now what's cosine 2 theta? Cosine squared minus sine squared. I know you're still kind of learning them, so it's okay. Eventually, these are the two you have to know, right? Sine 2 theta and cosine 2 theta. You need to make sure that you get those down. All right, so we're getting closer. Why don't we multiply everything out and just see what happens? So, 2 what? Sine cosine squared theta, good, plus cosine squared theta sine theta minus sine cubed. Well, that's good. We wanted to have a sine cubed in there, right? Yeah. And actually, we can combine like terms, yeah. 3 sine theta cosine squared theta minus sine cubed theta. All right. Are there any questions? Well, right here, these two, the terms are switched. Sine, cosine squared sine. It's technically the same. It's like x, y, y, x. 2 plus 1.
Okay.
Yeah. Oh, the agenda's up there, guys.
So you put 3 in front of like Kevin?
Yes. Like these two became that. Yep. Homework is day 2. I'll see you guys tomorrow. We're done a little early. Wow. Good job.